Hello and welcome. This webinar is organized by ETOL to launch their new app, RapidLCA. Some of you may know ETOL as a LCA software provider and LCA consultant. And today we would like to use this chance to introduce our new product to you. While we are waiting for others to join, I'd like to quickly go through the agenda and introduce our guest speakers. Richard is ETOL CEO and co-founder and is managing the software development. Richard has always been very passionate about sustainability and decided to dedicate his work to decarbonization of the construction sector, providing a tool that can help designers and builders make better choices. My name is Miriam. I'm Business Development Manager and have been with ETOL for 3 amazing years. In the past, I've worked in other sustainability industries, such as solar PV farms and electric vehicles. Jeff is project manager at Witchcliff, and he has been working for over 2 decades in architecture and town planning. Jeff's skills and passion for sustainable development fit perfectly with Witchcliff team. Having worked overseas, he helps to overcome many project challenges and generate novel design solutions for clients, as well as councils and local government. Jeff is thrilled to be working on the Witchcliff Eco Village, a project he considers to be the pinnacle of his design aspirations. Anita is a sustainability and innovation advisor at the City of Vincent in WA. She's been with the City of Vincent for about 10 years, heavily involved into policy development relating to environmental sustainable design and acting as an advisor to the planning team on ESG matters. Now our agenda today. We'll start with explaining what our motivation to develop this new application was. Richard will also tell you how much carbon can be avoided in the small residential space. I will then explain the methodology we're using inside the app and how it may benefit your project. We'll then hand it to Jeff and Anita, who will tell you about the first use of the app for a large zero carbon housing development, Witchcliff Eco Village, and another application as a part of the sustainability strategy and the design approval process at the City of Vincent. Rich will then share his screen and provide a quick demonstration to show how it actually works. And finally, we will have a questions and answer session to go through your questions. You will be muted during the webinar, but please feel free to post your questions in the questions tab as we go through the presentation. I hand it over to you, Rich.
Thanks, Maria. Yeah, so this application that we've developed's got a really long history. In fact, what we thought we were developing when we originally developed ETOL LCD, which is our, I guess, legacy application, was actually something that was going to meet this market. ETOL LCD didn't quite meet that market, but that core motivation of why we went ahead and developed that original software it hasn't changed, you know. In fact, it's probably increased. So, and I remember sitting down with Al, who was the co-founder of ETOL, and doing the numbers 10 years ago, and they haven't changed much. You know, there's over 10,000 new dwellings built every month in Australia. This is Australia alone. About 50% of those are detached. Another 20% are semi-detached. And it's really easy, really easy to save 200 tonnes per dwelling over the life cycle of those detached and semi-detached dwellings with a few simple changes once you know where the impacts are. And so it's over 20 million tonnes of CO2 that you could save annually over the life cycle of the buildings that are built every year. So just a massive opportunity, and we've never forgotten that. You know, ETOL LCD ended up serving, I guess, different buildings, larger buildings, but we've always remembered this, and that's why it was a no-brainer once we understood how to tackle this problem to go ahead with it. Just next slide there, Maria. Sorry.
Mm-hmm.
In terms of the markets, it's pretty flexible, but we are really this app is really focused on that low density residential market. So we've already got a little bit of uptake and amongst developers of housing estates who are seeking low or zero carbon outcomes, and also government authorities who are seeking the lowest cost with the largest environmental performance improvement for new development applications or building licenses. There's also potential in the finance sector. So, for example, banks seeking to offer discounted loans. Also, carbon credit providers may wish to sell offsets to homeowners, and also rating schemes may be looking at ways to reduce the cost of life cycle assessment while also improving the quality and consistency. So there's quite a few different markets, but where we're probably initially focused is around the property developers and the government authorities. Back to you, Maria.
Okay, thank you, Rich. It was good to hear a little introduction how it all started. So RapidLCA app is an app. However, you can also use it on your tablet or computer, and it can help you to design a more environmental house or the whole housing development. First of all, let us now have a closer look how much carbon is in one single house and how can we calculate if this house is really carbon zero. It can get a bit overwhelming for those who aren't familiar with sustainability and have only heard of renewables or energy efficiency. This is certainly part of the whole, but what about materials used? What about water? What about longevity of your house and future repairs? Are there any methods to calculate all of it? So the answer is yes, and it's called life cycle assessment. LCA gives us a calculation method based on the international standard EN 15978, and with this standard we know how to measure whole of carbon, whole of life carbon of construction project, and it helps us also not to miss anything on the way. So we look at a building life, usually 80 and 100 years, and calculate all materials that go into it: construction, transport-related emissions, actual use phase, repairs, maintenance, use of energy and water during this time, as well as the cost of demolition. And you may have heard of embodied and operational impacts. So there's a bit of a debate going on what is more important and what should be included. So World Green Building Council provides some clarity here. It says operational carbon is the module B6, and it's basically that use of energy in the house during its operation. We also think that the water should be included there as well. And then embodied carbon is basically the rest. So all these materials that are used during construction process, upfront carbon, so-called, right? Then the operational phase, maintenance, replacements, and end-of-life impacts. So with RapidLCA tool, you can measure all of it, and in a very short time. Here are the main benefits of RapidLCA app. Of course, you can calculate your carbon footprint, but this is just basics. We can also go further and try to minimize both embodied and operational impacts, which will then result in lower bills. We can then balance environmental outcome with its cost and understand how to achieve a set environmental target. So it can be, for example, 50% total carbon reduction or 100%. Actually, getting to 100% could allow you to achieve carbon neutrality even without the need to buy offset certificates. Another important feature is that if you have a large development with hundreds of lots, you can easily monitor and manage carbon of each single lot and manage this development in a single platform. Then, since everyone can do this calculation using the app, there is some quality assurance required, and this has been implemented in the app to certify your assessment and to make sure that the results are robust and correct. We also provide customized reporting for design approvals, build permits, applications for incentives or green loans. A certified report will prove that the house is meeting a set environmental target or outcome. And it's very easy to use. We have trialed the use of it with so many people with no knowledge about environmental design and received quite a positive feedback and great outcome. Summarizing, in this app, you can measure your future energy and water use of renewables, use of materials, and whole-of-life carbon associated with these products. In return, you're getting not only a house with low or zero whole-of-life carbon, but also lower energy and water bills that will translate into visible results on a daily basis. RapidLCA helps to design truly zero-carbon buildings, making both their occupants and our planet happier, and can be a powerful tool to manage your entire development. I'm sure you're now even more curious to hear from those who actually use the app and their story on why they decided to challenge the status quo of their industry. I'll pass it now to you, Jeff.
Thanks, Maria. Yeah, so I've been asked to give a bit of an overview of the Witchcliff Eco Village, and we normally give this presentation in about an hour and a half, and I've been asked to condense it down to 5 or 10 minutes. So it'll necessarily be an overview and leaving out a lot of details, but I'll do the best I can, and then I'll get to why and how we started engaging with eTool to do life cycle analysis for the housing that we're building. So it all started with the developers, Mike Hume and Michelle Sheridan, his partner. They've done a number of other projects elsewhere, up in Broome and Fremantle, but they always dreamed of doing a really, really sustainable project. And they were looking for a long time to find the site that we have. They wanted to find a site that had really good rainfall, good soils. They wanted something that was attached to an existing town site, and something that wasn't too far away from employment, and also importantly something that was already cleared of vegetation. After a lot of looking, they finally found the Witchcliff site that we're working on now. It's 120 hectares, 60 hectares of which is development area for housing. What they thought was going to take maybe 3 or 4 years to get approvals for, it's actually taken nearly 10 years to get all of the approvals in place. So it's taken a lot longer than they thought. Sometimes innovation is twice as hard, unfortunately, than just ticking the boxes. But hopefully it'll be worth it in the end. So we commenced construction on the project last year finally, and we're now in the sales phase. But just really briefly in terms of the project, the goals of the project were to create a residential and mixed-use community that was self-sufficient in water, power, had its own sewer system, and self-sufficient in fresh fruit and vegetables. So really encouraging people to think about where their food comes from and how that could be grown and delivered on site as much as possible. The other aspect was to create a development that naturally fostered a sense of community and connections between people. So that was a really intrinsic part of the design. So in terms of the project, it's 360 lots in total. There's 11 residential clusters, each of which surrounds a communal open space. So it's kind of a U shape. There's 3 different lot types: family lots, which are around 1,000 square meters, cottage lots, which are around about 450 square meters, and what we call our groupie lots, which are our affordable lots, which are about 360 square meters. Each of these lots is designed very carefully so that there's no overshadowing of the living space of the house next door. So each house can achieve really excellent passive solar outcomes for winter heating, especially down here where it does get cooler than, say, Perth. There's also an extensive mixed-use village center as part of the project. which is going to include a pub, a cafe, a backpackers hotel, mixed-use sites, a food hub, and a number of other commercial services. The village was designed to be very walkable, so all of the streets have are designed to be slow speed streets with tight radiuses on corners and street trees. And one of the unique aspects of the project is that the pedestrian network is mostly off-street, so mostly it goes through the center of the clusters, so along the communal open space, and you only have very discrete places where pedestrians cross streets, which is quite a different pattern to what you see in most new subdivisions. We've also worked very hard on the water-sensitive urban design of the project. There's a whole series of open planted swales that convey the surface water through the clusters and along the roads into the 3 large dams that we've built on site. So in terms of the water, we're in an area there is no scheme water. So all potable water for the housing needs to come from rainwater capture and tanks on site. So each house has their own rainwater tanks. There's irrigation that's plumbed back from one of the 3 dams back into the clusters, and so there's actually plentiful water for gardening because all the garden plots are actually in the communal space, not on the actual lots themselves. In terms of power, all of the power is going to be from solar power. All of the houses have to have at least 6 kilowatts of solar panels, and each of the clusters has their own centralized large battery, and the whole thing is connected up with a microgrid. The grid is connected back to the Western Power grid, but that's mostly so that we can sell back extra energy that we don't need. In terms of sewer, we have an on-site deep sewer system, and that treats the water to a high level, and then that reticulates it out onto an area around the plant, planted out with eucalypts. And those eucalypts are then coppiced from time to time for mulch, and that's brought back onto the community gardens. So there's a nice little closed loop there. In terms of the fresh fruit and veg, every house has a portion of that common property for their exclusive use for veggie gardening. And we have nearly unlimited amount of water from the dams for water for the gardens. So we imagine that those will be quite productive. There's also productive street trees along a lot of the streets, which include things like macadamia nuts, almonds, citrus, etc. So the whole place is going to be full of food, we're hoping. And then there's also the food hub in the village center that will be facilitating markets and marketing of food products. So we're trying very hard to make it self-sufficient in fresh fruit and veg. And finally, on the community side of things, the common property in each of these clusters has a small community building for meetings and yoga classes and celebrations, events. There'll be a fire pit, there'll be a playground, a covered orchard with chickens, and all of the houses are required to have low back fencing so that there's that visual connection with the gardens and your neighbors as well. And then we're hoping that people out in the common space gardening, that'll just be a natural way to meet neighbors and to facilitate those social connections. Finally, the village center is a pretty large and extensive one, and it's really an extension of the existing Witchcliff town site. There'll be a range of commercial lots there with attractively designed open spaces. We've got a big village square with beautiful granite stone walls. We've got a nature playground. We've got a small urban piazza, and we've got a playing field for kickabout area for sport. And the facilities that'll happen in the village square will really facilitate people working locally, and will create jobs and attract tourists, and also be a great place for the community to get together and socialize. Could I get the next slide, Maria?
Yeah, sure.
So in terms of, I guess in terms of getting back to the RapidLCA, we developed a series of very detailed design guidelines for the buildings that would be built on the lots. And obviously that focused very strongly on passive solar design. So we've incorporated a lot of those principles into our requirements. But we're also aware that that really only addresses the operational energy side of the equation. And we really wanted to understand what the I guess what the embodied energy impacts were. So we engaged with an LCA consultant in Perth, Andrew Moore, to help us understand which materials we should be promoting and which we should be avoiding from an embodied energy point of view. And that led us down a path to understanding that there was actually a lot you could do with life cycle analysis, and that perhaps we should start incorporating that somehow into our design review process. So that sort of started the conversation with eTool, and I guess when we chatted with Rich originally about it, he then let us know that this is something they've been thinking about for a long time anyway, and that perhaps by partnering with us we could actually help bring it to fruition. So the goal of our project is to be a carbon negative housing development, and the idea there is that if we can achieve that carbon negativity in the housing, that then we potentially, if you include all the infrastructure, all the roads and services, that overall we could be a carbon neutral project, which would be amazing. So over the last sort of year, we've worked closely with eTool to develop up the RapidLCA app, and that's now incorporated into our design review process. We have a target of negative 260 kilograms of carbon per bedroom, and that was set based on a 3-bedroom, 2-bath hempcrete house that we designed and had Andrew Moore analyze for us. A big part of this, of course, is the solar panels, but we're obviously wanting to maximize the amount of carbon negativity we can build in there, and so far our experience with the design reviews is it's quite achievable. We've done about 15 homes so far, and we haven't had too many that have struggled to meet that metric. Could we go to the next slide, Maria?
Mm-hmm.
So just to, I guess, to finish up the current status of our project. So we're currently selling stages 1 and 2, which is 109 lots, and we've got about 75 that have sold, and we had about 45 settled over the Christmas period. So it's been a really great and exciting launch of the project, which was only sort of from about mid last year. And so far we haven't done any advertising. It's all been through the website and through kind of word of mouth, I guess. Over the 10-year time that Mike and Michelle were getting the project approved, they started building a bit of a database of people that were interested, and now we've got over 2,000 people on our database. So we've really just been communicating with that database, and that's really what's led to the sales so far. We will be going out to market more formally in the coming months, and I'm sure you'll be hearing a lot more about the project then, of course. The civil construction of stage 1 is nearly complete. So the 1st of March we'll be starting to have buildings started on site, and stages 2 and 3 will be completed sometime in April or May. And we're actually just starting now design work on stages 4 and 5, which are the final stages of the project, and we're hoping to have civil construction start probably late this year. The village centre itself is currently under construction, and we're starting the design process for the community hall, which will be the first building that'll be built in the village centre, and that'll be probably ready by sometime late next year. So that's the current status, and happy to hand it back over to you, Maria.
Mm-hmm. Yeah, thank you so much, Jeff. It's been really such a pleasure to work with you guys on such an exemplary housing project. Makes me really want to move to Margaret River. Okay, and now I pass it to Anita to hear how probably the most open-minded council I know in Australia has embraced the LCA and decided to set some measurable targets for every development within their domain. So welcome, Anita, and over to you.
Thank you, Maria. And I must say, Jeff, you're definitely the type of developer we love to see in our city. I wish there were a lot more of you. So to introduce our city, we're an inner city local government just to the north of the Perth CBD. We have a very environmentally progressive community, and they've spoken loud and clear over the years and told us that they expect to see significantly better environmental performance from new developments in our city than what would be considered the status quo or business as usual for new development in the wider Perth metro area. So we have listened, and over the last 10 years have initially introduced and then gradually increased the environmentally sustainable design requirements that we place on new development in our city. And where we have arrived at is that all new development that requires a development approval in our city now needs to demonstrate a significant improvement in their environmental performance compared to business as usual. Could I ask you to move on to the next slide, Maria, please? Thank you. So this slide, I guess, gives us a little bit of an overview of where our current built form policy, the policy that our planners have to assess all development applications against, where we've currently arrived with that policy is that for residential developments, that includes all multiple dwellings and single dwellings, including detached houses and group dwellings, we now require them to achieve a 50% reduction on lifetime carbon emissions compared to the business as usual development that we would otherwise see as standard in Perth if we didn't have our requirements in place, and similarly a 50% reduction in net fresh water use over the lifetime of that building. Commercial developments will require 30% for carbon reduction and 25% for water, and that's having taken into consideration how much more difficult it can be for commercial developments to achieve those reductions, and we have worked with eTool to help us set those targets. And then for all other building types, we've got targets of the 50 and 25%. Actually, Maria, I think that might still be a typo on the card. 50, I think it's actually meant to be 30 and 25. That's okay. Happy to share our policy. So all building types just tries to capture everything that is not a residential or a commercial. Where the development is a mixed-use development, we ask them to do a separate residential and a commercial assessment for those two parts. So the reason that we've chosen to use a life cycle assessment as a methodology for our applicants to show their environmental performance is that we really wanted to be able to quantify what we were achieving with our requirements. Initially, we considered just creating a checklist that applicants could tick off certain technologies and design features on, but we rapidly realized that first of all, not all technologies and design features are going to be suitable for every context. And secondly, that we simply couldn't know how much of an impact we would be having through that kind of checklist approach. And therefore, we arrived at the life cycle assessment methodology because it quantifies very clearly the amount of carbon and water saved over the lifetime of each development. So the screen that we're on at the moment is actually showing an excerpt from our built form policy. On the left-hand side, it shows what we call our design principles and local housing objectives. The first three of those actually talk to the more qualitative parts of environmentally sustainable design and to some extent to the comfort of living in these types of developments. Those qualitative measures are also then reflected within the life cycle assessment, in that maximising passive solar heating, etc., is going to be reflected in the carbon performance as well. But we do want applicants to just take the time to really describe how they've achieved those. So that's what those first three objectives on the left-hand side of screen are about. The fourth one at the bottom is really referring to the the report that we require every application to submit. And for single dwellings and group dwellings, so those smaller residential scale developments, we do specify life cycle assessment as the methodology. You will see on the right side of our screen, the top part of the table also talks about the Green Building Council's Green Star rating system, which we accept as an alternative for larger developments, so large apartment buildings, mixed use and commercial developments where that Green Star rating applies. Currently, Green Star is really not yet suitable for those very small scale single and group dwelling type developments. So we do just specify the LCA for those. Can I get you to move on to the next slide, Maria? Lovely, thank you. So this is actually a screenshot of part of the fact sheet that we provide to the applicants who have got single and group dwellings coming our way. Those two types of dwellings are the most recent addition to the list of development types for which we now require a life cycle assessment or evidence of environmentally sustainable design. As I mentioned earlier, over 10 years we've gradually introduced these requirements, and we started originally only applying them to the much larger developments and have gradually brought them in for the smaller scale. Now we're at the point where it does apply to all developments that require a development approval. So this is really an excerpt from the fact sheet that we give to applicants to help them walk through that process, explaining what life cycle assessment is all about and how they would go about getting one done, trying to make it as easy for them as possible. Now, there's a lot of numbers there, and for a lot of people it can still be quite overwhelming, so we're doing our best to help them. And that's where RapidLCA really comes into its own. We've been really pleased to be able to work with eTool to help them develop and refine this tool because it creates a much easier pathway for applicants to be essentially able to do a DIY version of an LCA assessment where they can sit down and the app guides them through the process of doing their own assessment. That will still give us an outcome that we can interpret with quantified performance outcomes just as easily as we could a desktop study done through employing and engaging an assessor to do that for them. So can we move on to the next slide, please, Maria? Thank you. So this slide shows a little bit of a snapshot of what comes through to us at the city once an applicant has completed their RapidLCA assessment. First of all, on the left-hand side, it gives the planner who's assessing the application a really quick snapshot to show whether the development has or will achieve through their design our ESD requirements. So in this case, it's showing that this development would achieve an 80% saving against our target of 50%. So they're well and truly exceeding our target for global warming potential or carbon emissions, and that they're also more than meeting our net fresh water use savings. So that makes it really easy because immediately the planner is able to tick the box to say, yep, our ESD requirements are met in terms of performance standards. And then on the right of the screen goes on to the rest of the report, which then really provides that robustness in terms of the planners being able to drill down into where those greenhouse gas and water savings are coming from in that development. And I think Maria, thank you, Maria. She's just switching to the actual PDF version of that report to give us a little bit more detail. So that table above that we've just scrolled past basically shows which areas of the building and whether it's embodied versus use and so forth, where those savings are coming from in each of the areas of energy and water. And then further down, what we're looking at is each of the highlighted rows, the yellow rows, show where the applicant within the app has changed from the default template. So we've set our default template to essentially be the status quo, business as usual development that would normally be produced in accordance with the Building Codes of Australia without the addition of environmental design features. So that's what they start with, as their blank template. And then every change that they make to that template is shown as a yellow highlight, and hopefully every change they make improves the environmental performance. So that allows our planners to see very quickly where the changes have been made, and to, I guess, pick out and focus on anywhere where that change that's been made may seem a little bit out of the ordinary or perhaps a little bit unreasonable. They can drill down and maybe ask some questions and investigate, just in case somebody's really tried to put something unrealistic in, or they've made a mistake. But that is the overview of the report that comes out to us. It makes life easier for our planners, and it makes life easier and more affordable for the applicants. So we're hoping that in this way, we're going to get really great outcomes for everyone involved. And I think that is all from me. Thank you, Miriam.
Thank you so much, Anita. I'm sure now you'll get some more phone calls, not only from homeowners, but also from other councils across Australia.
Mm-hmm. Oh, we hope so.
Yeah, hopefully we can now have a few minutes to see how the app actually works. Which would you like to share your screen to provide a demonstration?
Yep. Let me get on top of the tech here, Maria. Thanks.
Mm-hmm.
So just got to make sure. Here we go. Is that, can you guys see that?
Yep, we can hear. Yep.
Awesome.
Yeah.
Okay, so I'll just refresh this. So what we're looking at now is the application as you'd see it on a mobile device. You can use it on a normal browser, and at the moment, I think most people are probably still using it on the browser. I'll just show you what it looks like there. If I can get this. So it's pretty much the same, but just on a bigger screen. I'll go back to the mobile view. And the reason, I guess from day one, we really wanted this to be easy and accessible. We wanted it, we're pitching it essentially in terms of the usability at sales staff and also homeowners themselves. And that's actually being demonstrated through the early adopters, Witchcliff and the City of Vincent DA applicants. And basically this first screen that the users will see is a list of featured designs, which will be continually updated as more people decide to feature their designs, and that will serve as motivation for people who access the application to see these high performing designs, how they've achieved that result, and get that inspiration on how they're also going to get a low carbon outcome for their design. The key thing there, I think, is trying to not only educate but also shift the social norm. So if people see all these zero or very low carbon designs coming through on the feed, then it makes it so much more attainable. I think at the moment there's probably a perception in society that it's somewhat unattainable. You know, there's a lot of negative press about the cost of carbon mitigation, and what we're trying to do here is make sure that people understand that it is very attainable, and we'll hopefully in a short period of time we'll have hundreds of designs up here that have got great outcomes. What I'm going to do is run through an example now. So, and the example I'll run through is a building with the City of Vincent. I'll do that for a couple of reasons. So Anita mentioned that the baseline design for City of Vincent was a business as usual design, whereas the baseline design for Witchcliff Eco Village is actually a really high performing design. So what I wanted to do was use a sort of more of a business as usual design so that we could show you how we can actually make changes to the design to get it towards that zero carbon outcome, rather than start at what is likely to be a zero carbon outcome just because of the specification that they've got down there at Witchcliff. So which generally probably results in a zero carbon outcome or very, very low carbon outcome. So what we do first is just search for the suburb. And what the app will do is bring up the pre-configured developments that are near that, near this location, near this suburb or town. If I was to search for something down south, or Witchcliff, I think it's anything within 50 k's. So even if I search for Margaret River here or a different suburb, we'd get those. We'd get Witchcliff up here as well. So, but what I'll do is I'll build a new lot within. I'll build enter a new design from City of Vincent. So I'll pick a suburb near City of Vincent, or in City of Vincent in this case, and then we'll select that government authority. The app's going to tell us how either the land developer or the government authority has configured things. So in this case, the lots haven't been pre-configured, so we need to create our own lot, and it hasn't been prepaid either. So before we see the detailed results, the users will have to pay for the use of the app. So what we'll do, it also tells us the targets. So in the case of City of Vincent, it's a 50% reduction in global warming potential and net fresh water use. Should mention there as well, the net fresh water use is life cycle net fresh water use. So it's not only net fresh water use in the operation of the building, but it's also embodied water in materials or electricity supply, whatever it might be. So it's a comprehensive metric. So we'll put a, this is just a made up address here. And we'll give it a description, and then we'll start designing. So I should mention on this, so what's happening now is the app is loading up that baseline design and effectively creating that base case for us. One of the aspects of the way we're measuring performance in the app is we really want to make sure we're recognizing functionality, and we're doing that by the inclusion of the occupants in our functional unit. So the more occupants in the dwelling, all else being equal, the better it'll perform. Obviously there's going to be an increase in our estimated energy consumption with more occupants, but there'll be a decrease in impacts associated with things like materials, etc., per occupant, because we're measuring per occupant if we have a higher number of occupants. So what I'm going to do first of all is just design a home that's a bit of a sort of not an overachiever, if you like, and then we'll come back and optimize it and see if we can get to a zero carbon outcome pretty quickly. So just looking at my watch now, it's about 17 minutes to noon where I am in Perth, and we'll get an idea of how quickly we can conduct an LCA. So let's assume it is one dwelling. We'll assume it's 3 bedrooms though. We'll say 2 bathrooms, 2 car parks. We'll leave it as a garage, but we could choose carport here if we wanted to. We'll say it's over 2 levels, and we'll give it a bigger ceiling height, and we can customize the gross floor area here as well. So, but and the way the app works, and we should mention this, is it's what we've used is eTool's historical database of similar projects. So although most of, I guess, the success of our original platform was around larger buildings, we did actually still use it quite substantially for these smaller buildings. So there was over 100, I think close to 150 LCAs that we conducted in this sort of lower density residential space. That enabled us to produce some regressions on what the key inputs are for design. So what do we need to know to get some level of accuracy within the results? And so we can enter a small number of inputs here and get really good accuracy on the results, which is how the app's designed to be used. But I'm going to customize the floor area here and say that they've their floor area is a little bit bigger. And then I'm going to leave most of these other selections on this page just as per the defaults. And then we're going to customize the design a little further by selecting some different services, etc. So in this case, I might change the hot water system to, let's go with a heat pump, hot water system. And I might also change it to an induction stove, just so I can go all electric, save on the gas connection. I can then customize the plug loads. In the case of City of Vincent, most of this is locked down. So we're in discussions at the moment about whether we should give people information about individual appliances, such as televisions and things, how much they actually influence energy use. And we may introduce something that enables people to at least see that and model as an off-axis sort of scenario what they can do in terms of appliance selection, which is pretty significant. The one thing we can change here is the fridge space. So depending on the size and how well ventilated the fridge space is, that is going to have an effect on the refrigeration energy. So we'll assume that they've gone with a smaller fridge space, which sort of reduces the ability for occupants to have an unnecessarily large fridge. And also a well-ventilated fridge space. So something that, if I've got a picture here, don't have a picture in there, but just something that's going to allow the air to flow up the side of the fridge. Actually, I think there's a picture in one of these other ones. Yeah, here it is here. So not easy to see on the mobile screen. That's a bit of a glitch there. I need to send that back to the devs. But we'll choose this other one, which is the smaller opening as well. But in most cases, when you're clicking through on these options, it'll give you some guidance on what you're selecting. We will change, there's going to be more transparency on things. We'll put a small PV system on this building. We won't change any of these other ones. We'll leave the swimming pool at 0 meters squared. Assume there's no pool in here. We can customize the structure as well if we like. Again, I'm going to leave this initially, but we'll come back to this when we go and really optimize our building. What I might do is just change this elevated floor to a thicker slab for the elevated floor. So it's pretty easy to make changes to the design and really customize things. We might customize the floor finishes as well. So perhaps we could do something like polished concrete for the living areas, and we'll do that for kitchen dining as well. If we want to customize actual quantities of these different things, we can, but that's really up to the user how detailed they want to go with the assessment. So I've got my initial results. I think we started at 17 minutes to, and it's now 12 minutes to. So we've got our initial results within, 5 minutes basically, 5 or 6 minutes, and we haven't hit the target here. So we can see here that we've only got a 28% reduction in global warming and a 10% reduction in net fresh water use. So we can see, if we want to analyze this in some detail, we can just click on this item here, and we can chop the results up depending on how we want to see the results. So we can see it by life cycle stage. So we can see that construction stage impacts are quite, or the plug loads, which are pretty hard to influence for a designer, but I will go into that in a minute of how we can influence that. They're quite large, the largest single sort of life cycle stage, if you like. Construction stage products are quite large. Use stage integrated energy. So you can see the energies, these two combined is a really large parts of the building performance, but there are also these other embodied impacts which are really significant actually in terms of the carbon. we can chop this up and drill down into the energy, and we can see what's driving the energy performance. So HVAC's number one, followed by entertainment appliances, then refrigeration, and so on down the list. You can see the domestic hot water heating is pretty low, so we did select a heat pump on the way through there, and that's obviously had a positive effect there, but we've still got some other opportunities for improvement here. And then we can look at materials, and we can see that concrete's number one, followed by the bricks, blocks and pavers. So we started with a double brick wall as the baseline for this one. And then the gases, so this is refrigerant gases in some of our equipment is coming up as a big impact as well, so some opportunities there. The construction impact, so this is the actual impact of your construction equipment, and this is actually pretty small. The bars on this relative to the other bars are quite small, so it's probably not a big opportunity for improvement there. But what we might do is just go back into the design. Now, in order to make changes, we can do this in a number of ways. We can just click on those buttons and it will show us the components that are driving that result. For example, if I clicked on the HVAC there, we can see that there's these two components are contributing to HVAC energy. Similarly, if I jump into materials and click on the concrete, I can see there's lots of different items in the building with concrete in them. These will be ordered from highest to lowest in a similar fashion to the previous screen in future releases, so it'll make it even easier to identify where those impacts are, where you've got lots of selections like that. The other way I can change things is actually just go back to the start. It preserves all your selections, but I can actually start making changes and go through the process again. So what I might do now is see if we can get to a zero carbon outcome quickly. So we're now at 9 minutes to 12 where I am. So I'm gonna try and optimize this design so it's really quick. Now, some of the changes I'm going to make are pretty disruptive. You wouldn't want to be doing this late in the design process, but that's one of the advantages of this tool is it's so easy to model something that you can do it even before. You can do it at the brief stage just to understand even what your target might be for a dwelling. So I'm going to change this to a dual key residence and give it 4 bedrooms, so like a sort of a separate flat within the dwelling. So we've got a 3-bedroom residence and a 4-bedroom residence. We'll bump it up to 3 car parks, and we'll leave it as a garage. We'll leave it as 2 floors. We'll leave the ceiling height. I'm just going to let this calculate automatically again, and I'm happy with that as an estimation for the floor area, but I could customize that if I wanted to. I'm going to put some integrated energy monitoring in. So for each of these selections, these configuration selections on the screen here, it does give us some additional information. So we can, if we don't understand what it means, we can read through it and understand that. For the thermal performance, I'm going to assume that we do what's necessary to get it to a 7-star rating. So that's going to improve that HVAC requirement, the heating, ventilation and air conditioning requirement. The lighting level, I'm assuming that we've got I'm going to assume that we can put lots of north facing windows in here so we can get it up to a high level of natural lighting. I'm going to put a small water tank in for the water supply. I could select grey water treatment if I wanted to as well, but I'll leave that out at this stage. And then I'm going to go fairly high efficiency with my fixtures and fittings through here for the water. Now you can see here that we have required some appliance water ratings here, and the reason we asked for that information is because the water, there's a bit of a feedback loop. So the water that's available, if we did have a grey water system, for example, the water that's available for that grey water system is dictated by the water that's going to be produced by some of these appliances. So it's one of the areas where we kind of deviate from just the design only to include appliances. So I'll choose 4.5 star washing machine and a 5-star dishwasher. And then the garden type, I'm going to go for dripper irrigation and subsurface lawn irrigation. And then I'll choose a rainwater pump with a pressure vessel to reduce the energy associated with that. I'll go in here now and specify some higher efficiency lighting. And I'm going to go, what do we have here? So this is our cooling system. I'll leave this as a air source heat pump, but I'm going to choose a high efficiency split system with a coefficient of performance and an EER of 4.4 or above, and also the R32 refrigerant, which is a lot lower carbon. So yeah, when we were looking through the materials, I remember gases was right up there, and I think this is one of the drivers of that. And I'm going to swap my heating system out with a pellet heater. So it uses biomass for heating. So, but in a really convenient fashion. It's sort of, yeah, they can turn on and off, etc. A bit like a gas heater, I guess, but using biomass instead of a fossil fuel. I can't customize plug loads anymore. I'm going to increase the size of my PV system. So when we added the extra dwelling, it scaled this up. So you'll see that most of our quantities are scaling depending on what we enter on that first screen. But we can come in here and customize that. In fact, because it's 2 dwellings, depending if I had separate meters, I could actually probably put a bigger PV system. I will just leave it at, I think, probably about the max you can put in this jurisdiction is about 6.6 kilowatt on a 5 kilowatt inverter, I think. So we'll put that in there. I'm going to reduce the area of my outdoor lighting down to 50 square meters, and I'll put a higher efficiency outdoor light in as well. Sorry about the dog there. Someone just banged on the fence. I'll leave the pool out again. I knew in our analysis we saw that concrete was really big on the list, so I'm going to swap this out with. Have we got fly ash? Yep, we've got some really high fly ash options here. So I'll go with. So this is effectively a geopolymer concrete, so something like 90% fly ash to replace the cement. For the upper floors, I might go for a timber. Something like this, timber upper floor to reduce that reliance on concrete. We can go timber staircase as well. And then the other thing that came up quite as a pretty high impact item was the bricks from memory in this one. So I'm going to change the upper floor to a lighter frame construction. This is the internal walls. Oh, well, I'll change that as well, actually. And my upper floor external wall, I'll change that to light frame as well. Here we go. And then I might go for timber floor instead of carpet in the bedrooms, which should be lower impact. Although I didn't see carpet in the highest impact items. So we've got to an 86% reduction in carbon and a 55% reduction in net fresh water use. I can drill down here and have another look at what's sort of still giving us grief. Actually, the embodied impacts of the PV is actually starting to add up here, which you'd expect. There's still some refrigerant gases, so yeah, there's still some room for improvement there. I can't optimize any further because time's up, but hopefully that gives you enough of an idea of how the app works.